Okay, this is the second lesson in our solution chapter, and in this one we're going to talk about factors that affect solution preparation, solution prep factors. So you might want to pause the video. I have redrawn our crystal lattice structure of sodium chloride from the last chapter, and I've thrown some water molecules around it, including the partial positives and partial negatives. So go ahead, pause the video, copy this down. Okay, here we go. So if I've got a beaker, and I'm going to fill that with water. I'll do a couple of things as a demonstration in the classroom. The first thing I do is I'll throw some, I'll ask the students if they're ready for a magic trick, and I'll throw some salt into the beaker and I'll stir it and the salt disappears. And I always say it's a little bit of an underwhelming demonstration, but have you ever thought about why that salt goes away? What is it about this scenario that causes the solid of the sodium chloride to split apart and disappear and become suspended in the solution? What I'll do next is I will take a couple of chunks of rock salt and I'll toss them into the beaker. And they just sit there and they don't do anything. And I'll say, okay, so my first salt dissolved really easily, but these don't. So what could I do to help get these to dissolve? So think about that for a second. I've got 2 chunks of rock salt in my solution. What could I do to cause that to dissolve? Did you say crush it, which would be accurate? And then I'm going to have lots of kind of smaller chunks, but what could I do next? Did you say stir it or heat it? And if you did, you're correct. But the bigger thing we're after is not only the what do you do, but why does it work? So let's talk about over here on this side of the page, the process of dissolution. So on this side of the page, I want to talk about the mechanics of dissolution. And remember, we said in the last video that dissolution is the process of dissolving something. So here I have my crystal lattice, and I have my positive cations with alternating anions stacked up in my crystal lattice. And around that, I have water molecules. Well, I know that we talked about the fact that when we put these ions into a compound, that the charges kind of go away. They kind of do and they kind of don't. I still have on these sodium ions a positive charge, a negative charge on the chlorine. So I've got, whoops, positive 1, negative 1, positive 1, negative 1, negative 1, positive 1, negative 1. Well, think about what we know happens with charges. I now have charges around this ionic crystal lattice, and I have charges within this ionic crystal lattice. What do you think is going to happen? Can you make a prediction? If I have a negative charge here and a positive charge here, what did we say positive and negative charges do? That's right, they attract. So I get a pull between this positive sodium and the negative, partial negative charge on the oxygen. Over here, I have a partial positive on my hydrogen. So I'm going to get an interaction or a pull between my negative chloride ion and the partial positive on the hydrogen. And what we see actually happens is at the solute-solvent interface, and the definition of an interface is where 2 things meet. Where they meet. The charges, the partial charges on water attract the ionic charges. And what happens is these pulls, we have a pull here, we have a pull here, we would have a pull here. We could do more of these. This force pulls apart pulls apart the crystal lattice. So we exert forces all the way around the outside of the interface. So I'm just going to write the interfaces here. And it starts to pull these ions off of the crystal. Well, why do these not want to dissolve? My finely ground salt would dissolve, but this doesn't, because there is a lot more interface on a finely crushed solid. I have a lot more surface area exposed. So the first thing we can do to increase our solution, to increase dissolution. So what we want to do now is we want to talk about how do we increase dissolution. And number one is we have to, we can crush our solid. So it's not enough that you memorize the bullet points. You also have to know why. Crushing the solid increases our surface area, which leads to more interface. And we said that this force pulls at the interface. So if we increase our interface by increasing the surface area, we're going to increase dissolution. All right, if you said stir our solution, you would be correct. So we're going to stir or agitate. And what we're going to see is when this water molecule pulls off, let's redraw another molecule here. Let's do an OH. When a water molecule pulls off an ion, the ion kind of stays attached to the water molecule. So I'm going to have a sodium attached here, and I'm going to have a chlorine attached down here. And there's no more pull, because this positive and negative are used up here, and this positive and negative are used up here. So when we stir or agitate, we're bringing fresh solute into the interface that doesn't have atoms or ions bound to it. So stirring or agitating brings fresh, unused solvent into the to the interface. So if I stir, if I pull all of these off, these kind of just sit here, and then we don't have any more dissolving. If I stir, once these pull off an ion, they get pushed away, and we bring in another one that's fresh, and it pulls off an ion, goes away, and so on and so forth. We're constantly bringing that fresh solvent into contact with the crystal lattice that lets it pull off ions. The third thing you probably said was heat the solution. And this has the same thing. It brings in fresh solvent, but it does it through collisions. So when we heat the solution, the molecules of solvent move faster. And this faster moving solvent brings fresh solvent to the interface. And it increases the collisions between the solute, both the number and the intensity. So these water molecules, because they're moving faster, they're coming and they're hitting harder, boom, and they're pulling that the ions off. All right, so what are our takeaways here? How do we dissolve? We have the solute solvent interface, and all of this around the edge of our lattice structure is our interface. And there's a force that's exerted between the water molecules and the ions. Doing these three things will help the process. If we crush our solid, we have more interface because you have greater surface area. If we stir it, we're taking up the used solvent out of the way and we're bringing fresh in. If we heat it, we're causing these water molecules to come in and hit harder and more often, and then we're also pulling them away and bringing in fresh solvent. So we can't just say we're going to crush, stir, and heat. We have to understand the mechanics behind it. Okay, that's it for now. Now we're going to start to look at some of the properties of solutions.